I'd like to introduce Dallas Shepard. He's our precision ag agronomist for our Salem location, and he's got several years of scouting experience, precision ag experience, and he really does a great job in his area in delivering just awesome service to his growers. Up till now, we've been talking about data, making sure it's good, accurate data and to make decisions. Well, I want to have Dallas talk about some successes he's had in his locations and how they put that data to use. So if you want to, Dallas, if you'll kind of fill us in on what you've been doing for your growers in your location.
Thanks, Todd. Yeah, guys, so I've been working with technology and agronomy for about 8 years, and really what I wanted to do with kind of my slides and my presentation was to show how all that ties in full circle, where you take the agronomy side, then you take the precision and the technology side and tie that all together. So kind of a good story that I had was a new grower that was involved with our precision ag program for the first year this past growing season. He was new to security seed and he was new to our secure crop system. And so what I really wanted to do was show where we started from the start to where we ended up at the end, to where I can show you guys how this kind of goes full circle. So first what I did when I met the grower is kind of asked him where did he want to start, you know. And a good question was, is you have to know where you're at to get to where you're growing, or a good statement. So when we first sat down, I wanted to really touch on what all went into our precision ag program. Now, like some of the stuff that Todd and Patrick have talked about earlier in some of their slides, was explaining what differs us from other groups. Now, this grower actually had used some technology on the farm with the precision ag, and had a lot of equipment technology, but wasn't using it to its fullest benefit because he didn't have good information. So really what I wanted to do was gather as much information as possible that he had, whether that was historical field data, soil fertility levels. He had been grid sampling, and I showed him the difference of our management zone sampling, and we're on board with that from the very get-go. We were able to gather some historical field data, so we had some information we could kind of go off of to start building a story. Secondly, we wanted to make a plan, and what my biggest focus working with growers is you have a team with your secure crop system. You have your secure crop agronomist, you have your sales agronomist, and then you have Todd and Tom in the background bringing a lot of new precision ag technology to the front for us to take it to the field. And then you also got Patrick and Dustin with all their research trials and all the products that they're testing. But then you also got Lang as a fertility agronomist that's always helping us make the best recommendations. Next, can I bear VRT? This grower in particular had a lot of capability. He wasn't your largest grower, but he had a lot of good capability equipment-wise to be able to use a lot of technology on the farm. What type of inputs was he using? This is a predominantly chicken litter application for fertility mainly. So what we needed to do was take some samples to see, hey, you know, with your soil fertility levels, is chicken litter your best fit? And the next thing was budgeting for predictable results. As you can tell with a lot of Patrick's work on the research farm, a lot of the results we're getting on there are predictable because we've been doing it for so long. So we've been testing this system approach on farm to where we can bring it to you, the grower, and say, hey, this is stuff that we've been testing and we have good predictable results with this. And then lastly, with the technology, what can we do to find limiting factors and try to eliminate some of those limiting factors? Next we went into implementing the plan. We wrote numerous VRT recommendations for fertility, seed, and nitrogen. And then we looked in where we could, on those limiting factors, where we could reduce those input rates with new technology and products. Then we went right into following through with the plan during season. This grower was able to do some of his own in-season nitrate sampling, and we tested that with our 360 nitrate sampler. And then he also did some target tissue sampling through some NDVI imagery that we loaded up on his iPad.
Now, Dallas, you were able to be flexible enough to bring some flexible solutions to adapt to his equipment
Correct.
his soils, his goals,
Right.
and what he needs to deal with. You were able to bring enough flexibility to kind of fit in there, wasn't
Right, and kind of what I like to do with growers is we cover such a big footprint. We can see what works on one grower's operation and maybe bring that technology
Right.
to another grower. So not every, I'd say everyone we work with, no one's the same.
No.
Everyone does everything a little bit different. But with us covering as many acres as we are, we're seeing what works on some other operations and being able to bring
Right.
some of those options to them. And then lastly, what I try to do is really show a good harvest report card and how did we do? How did we show him a good return on his investment for what products he put where, how we place those products using all the agronomy and precision ag technology that we gathered throughout the year. So first, here's a good example of just gathering information from the ground up. You know, we didn't have a whole lot, like I said, but we were able to gather some historical yield information and some NDVI imagery. Todd, what do you think about the satellite imagery as of late, well, at least the last couple of years?
The satellite imagery has really taken off. It's not been too many years ago that you didn't get very many flights.
Right.
It might be 2 weeks, every 3 weeks we get a flight, and if there was cloud cover, you didn't get a usable image.
Right.
Now we've got satellites coming overhead every 3 to 5 days, so you're getting a lot more access to satellite imagery, and the cost has come way down.
Right.
As part of our program, you know, it's built in at no extra cost.
Unlimited imagery.
Unlimited, so it's really come into its own the last couple of years.
This is just a good example of one of the images that I was able to capture this year to show you the variability in the field. And then also I used his historical yield normalization to make some decisions as well. I took 3 years worth of information. I kind of put it all in a box, and kind of how I tell guys is as that information all goes together, the computer will spit out, say, hey, out of 3 years, this is your below average areas, this is your average areas, and this is your above average areas. So now we can kind of paint a story of, hey, this is where we're going to start to reallocate some inputs on your farm instead of just looking completely at a flat rate scenario. We're going to try to start putting some inputs where you get your biggest bang for your buck.
Now that data that went into, like for this example, the historical yield normalization, now you truthed that yield and cleaned it up and made sure
Yes,
that, and validated
Right.
that it was correct.
Right, yeah, this
There
is just
wasn't
not
machine
something
errors.
we just completely took right off the monitor and it gave us a pretty PDF map, or even this map at all. We had to bring this information in, made sure the swath width was right, the header height, you know, took out a lot of your just common errors that would be straight off of your monitor. And
So we wouldn't get misled.
right. This is a real good example. What I wanted to do starting out with the grower last winter was sit down and show him just how variable some of his fields were. And I know we can always talk about yield with variability, but I really wanted to show him how this affected gross revenue. So this is a map of sample zones that we built to be able to composite sample those zones. And what I wanted to do was tie yield. So what these zones are broke out is yield per zone, but then also gross revenue per zone. And then there's a huge difference in gross yield, you know, anywhere from 140 bushel down to 257. So we almost got we got about 100 bushel swing in the same field. But then when you tie it back to gross revenue at a $3.50 bushel market, you're looking at $400 per acre difference in gross revenue. So, you know, in years previous, this would be a completely flat rated scenario. So he's putting the same amount of money of his inputs into that 140 bushel yield environment and the $512 gross revenue zones as he would where he's pulling 257 bushel off of 900.
And we may not even need those inputs.
Correct. You know, we don't even know, you know, like I said, starting out with this is before I sampled this at all. I was just saying, hey, there's quite a bit of variability. You know, is that variability in soil fertility levels? Is that just a sandy corner? Is that some poor drainage? So as I was gathering all this information, I was able to sit down with the grower, and he was able to kind of talk to me and let me know a little bit more about his operation. And you know, he knew that was a pretty weak spot on this particular field, but he didn't know how bad it was until we tied it back to gross revenue. You know, that also goes into fertility budget. So good rule of thumb that we like to use is guys would use about 20% of their gross revenue on a fertility budget, including their nitrogen, potassium, phosphorus, and all their micronutrients. And that kind of gives us a starting point. We want to stay in about that 20% range. So goes back to fertility budget, $102 per acre on a fertility budget, all the way to $180, where he could reallocate some inputs. And then you can see the same slide with the gross revenue. So we do have a lot of swing in gross, or we have a big swing in our fertility budget where, if we were looking at a flat rate scenario, we have an average fertility budget per acre of $154, when we're pulling a lot bigger yields off of some of those high yielding areas.
So I guess with a good, accurate soil sampling plan and program, you were able to get good information to try to identify that limiting factor. If is it a P and K question, or is it zinc?
Right.
Where should that money be spent first?
Right. Well, and we didn't know, so the next thing we went right into is we used our Explorer app. We actually built these zones and we loaded that Explorer app that we've gotten through our Fieldalytics platform, loaded it right on his iPad, and he was able to go out and sample it himself. So he didn't have to hire anybody else out, and he was able to sample it himself and felt like he did a good job and know what kind of job he's getting. And I think.
So did you see a lot of savings there?
Yeah, I think we saved him roughly about $5 per acre compared to his normal soil sampling service. And how did that information come back? So here's a good example of our soil fertility levels. It gives us a good sample summary map after we get those soil fertility levels. And what I really wanted to focus on was, hey, we're giving these guys a in-depth soil sample where you're getting all your primary nutrients, your secondary nutrients, and also your micronutrients. Looking back at some of his old soil tests, he was only getting about a basic 2, so he was missing a lot of his micronutrients. This is a high yielding field, so micronutrients plays a big role obviously in this. So what I really wanted to stress to guys is, hey, everything that runs through our platform would be a full soil test. Get a full soil test run.
Micros, the whole
9 yards.
Base
and then,
saturation.
If you needed to try to hone in on trying to find some aluminum, that's when we would dive into that. But we run a full complete test through.
Now I'm seeing this fertility diagnostic query. What can you tell us about that?
Right, that's something that I guess would be proprietary to what we do. And what we wanted to do was this is just a red flag system. It's not an actual soil test, but it's allows the secure crop agronomist to have 2 screens up when they're looking at your soil fertility levels, and it just throws red flags saying, hey, if you over 50% or 75% of your field is red, hey, this is something you need to kind of check into. Or if it's green, it's something that you don't have to worry about. And that's all based around base saturation levels and how excessive or critical levels of different nutrients affect other nutrients or antagonisms. Brings
your problems really into focus.
Correct, yeah. So I guess a real good example how some of those look is we dive into excessive base saturation of calcium for phosphorus, and that it throws some different parameters up, and then also has some comments on, hey, if you have 75% base saturation of calcium, or if it's higher than 75%, it tends to tie up phosphorus. So it's saying, hey, if that was the case, if that field was 3/4 high in base saturation calcium, don't go throw out 200 or 300 pounds of DAP.
You're not going to get that maximum ROI that you're needing for build.
It really say, hey, you need to split apply that product, you need to protect that product, or go with an in-furrow situation.
Or wide drop.
Or wide drop, abandon those products. And my next few examples are going to really go into how I use those FTQs and tie those all for my fertility recommendations. So the biggest thing that jumped out to me on this particular field was holy phosphorus. So this was some of the highest phosphorus levels that I had seen working with a lot of soil tests. Everything was over 100. Like I mentioned earlier, the normal practice on this field was chicken litter applications, and right off the bat, I was like, hey, phosphorus is not a limiting factor, especially when you're looking at in the hundreds. But
would be money well spent.
Correct. And what I wanted to do was saying, hey, now that we have the soil test and we have this information, what would have happened if he goes out there and throws another 2 or 3 tons of chicken litter on this? And right off the bat, my FDQ throws up a red flag. Like I said, 98% of the field was red, so we've got a problem. We need to check it out. And kind of the comments there you can see is P high critical. With excess P levels greater than 100 pounds per acre, it's going to throw a red flag. And with those high P levels greater than 100 pounds, it blocks the uptake of zinc. So what we did in this particular scenario is we did not spread chicken litter at all. We put 3 gallons of the ProGerm product in furrow, but then we spiked it with, we ran a quart of micro 500, but then we spiked it with a 2x rate of zinc because he had so much phosphorus was tying up or blocking the uptake of zinc. And kind of the analogy that I like to give the grower was, hey, with these high phosphorus levels, that corn plant is going to just eat phosphorus up like it's candy.
Right.
But we know we have to have a balanced diet and a balanced nutritional program. Well, his zinc is over there like his salad or his carrots. So he's just eating candy like it's going out of style, but he's not getting the right amount of zinc. So by allowing us to ban that zinc, it made that zinc a lot more efficient, a lot more uptake of it. So he didn't have to go out and work.
Money well spent.
Correct. Next, I want to look at my potassium levels and how that all correlated with his phosphorus levels and my base saturation levels. So, if you guys remember at the first slide, we didn't know the soil fertility levels or what was the limiting factor up in that corner. As you can tell, our potassium levels are plenty high in that area. So soil fertility right here is not a limiting factor. We got areas in the 400 to 500 pounds in the soil, but then how does that correlate to our CEC? We've got 20. We've got a soil test of 20 over here on our CEC map. Well, those areas can hold a lot of nutrients, right, and that's why they've held them there. But we're not pulling the yield off.
Right.
So on this particular case, potassium is not a limiting factor either. How does that correlate to my FDQ map when I'm looking at that? Because I guess a lot of guys, when they would see this, or if you were working with maybe just a complete dry fertilizer company, they would see those and say, well, if you're not going to spend the money on DAP, or if you're not going to spend the money on chicken litter, we'll put 500 pounds of potash and call it a day.
Right.
But as you can tell with those FDQ maps, there's a lot of variability in those potassium levels, and with the calcium as high as it is on this field, we just can't hold that much potash at one time.
And we're probably seeing a yield drag too, wouldn't you think?
Yes, I would say so. I mean, if you can tell over there on your potassium levels, look how much variability, where you notice exactly where those high yielding zones are, how we're pulling those potassium levels are, but those are also our lowest CC levels as well. So we can't go out there and hold a lot of potassium at one time. So in this particular case, we split applied our potassium. We used a variable rate, I can just go right into the next slide. We used a variable rate potash recommendation, but then also we put 2 gallons of Calibrate, which is our potash and sulfur product, with the Y drops. So what I want to do is put plenty of potassium. So kind of looking at this scenario, I wanted to mend the soil with my potash, but then also take care of my plant and my plant nutrition through banding it with the Y drop. So
get maximum efficiency with these soils that we've got these problems with.
Right, yeah, so it has a lot less tendency to tie up because of the high calcium levels. I was able to band it right there with the Y drops, and we put 2 gallons of Calibrate, which is our potassium and our sulfur product. With that, we ran that potash recommendation. That's just an example of a variable rate potash map. As you can notice up there in the corner, we got 0 rates because of those levels were so high. But we did take care of the plant and the nutritional side with the Y drop as we came back. So what we're trying to do here is just amend the soil, get those potassium levels up. But it didn't start there. Also with my FDQ maps, I was able to take advantage of trying to fix some low base saturation of magnesium. So as we're looking at base saturation levels and trying to balance those out, I noticed a lot of his, or at least half of this field was low in magnesium.
That's a big problem in our area.
Correct, yeah. So this particular scenario, what I wanted to do was take a product called Trio or K-Mag, which is 22 pounds of potassium, 11 pounds of magnesium, and 22 pounds of sulfur, and use this product with my potash recommendation. So how this got applied was a retailer came in there with a dual bin spreader and spread this Trio or K-Mag product on one side of the bin, and then the potash recommendation on the other side of the bin. And he was able to spread both those products at one time, variable rated it throughout the field. And with that, with the technology that we've got, we were able to use that Trio or K-Mag recommendation and give our potash recommendation a credit. So we knew, for every 100 pounds of K-Mag or Trio that we spread, we're going to get 22 pounds of potassium out of that. So what I wanted to do when I did that was give my potash recommendation a credit for that.
So kind of a multiple mode of action on your fertility, just like you would with herbicide.
Correct, yes.
Get your maximum efficiency.
Right. And saying, hey, with that elemental sulfur, I'm going to be able to strip some of those calcium ions to be able, that magnesium to be able to take place. But then also, if I have any parking spots left, I should be able to build my potassium levels in the soil too.
With good information, you can make some good agronomic decisions to try to get a plan to put together with good information.
Correct. So we, not only did we make the variable rate potash recommendation, but we took it one step further and saying, hey, we know we're low in potassium, we know we're going to spread some potash, but we can't just stop there. We've got to take it, we're doing all this work, so we've got to take a deeper dive into that. So that's why we opted to use this Trio and K-Mag. And we're seeing a lot of growers using this Trio or K-Mag product in a dry form, also in a liquid form.
To address a lot of these magnesium issues that
Correct,
we have.
yeah, a lot of this tissue sampling that we've done early, especially on some early corn and wheat, is if you're looking at a soil test, your magnesium levels will be high, very high, but if you look at how that's correlated to base saturation levels, they don't respond. So we're seeing a lot of our base saturation levels of magnesium less than 12%, but there's plenty of magnesium in the soil. So it's saying, hey, is the calcium so high on a base saturation level, is that tying up the uptake of magnesium? And that's the thing that I attribute it to is, hey, we're going to start having to amend the soil a little bit to make some of that magnesium available.
Sounds like a good plan.
Next, after we took care of the fertility and the fertility budget, we went right into his VRT seeding recommendations. This is a good example of what you would be getting from our secure crop team on a VRT seed rec. I had broke this out with 4 zones. You'll see familiar that multi-yield yield normalization map. I tied that right back into his seeding rec map. Sat down with the grower and said, hey, does this look right? Is what the variability you kind of see in the cab? And it matched up real good, real well.
Truth in the information.
Right. I wasn't just doing it on my own or just let the computer completely do it. I wanted to bring that information to the grower and say, is the technology that we're using painting the right story for us?
Trust and validate.
Correct. So, we broke it out into 4 zones, broke it out in different those acres of those zones, and you can see, have average rates of 30,000 all the way to 36. And then, typically this grower would plant this flat rate would plant this field 33 to 34,000. So we landed right in there where we needed to be. And kind of what I want to touch on as well is a lot of growers taking advantage of this multi-hybrid systems.
Right.
We are writing recommendations for that. The new technology with the dual or multi-hybrid planters, we're able to write recommendations for a defensive hybrid and then an offensive hybrid, and have a couple different rates for those too. So we're not, we're staying ahead.
Yeah, I'm hearing that's going to be huge. Everything I've seen, it's going to be very beneficial and it'll grow rapidly once people upgrade their planters
Correct.
with the new technology. Everything I've seen as well, it's
So I'd say
solid.
I think with some of our secure crop agronomists, we deal with about 3 or 4 of those in our footprint. So we're just now getting the information back and running that through and seeing how that correlated to yield. Next we dove right into our VRT or our nitrogen application. And really what I wanted to show guys here is starting out, we did not have variable rate technology on this side dressing rig. What we had was a Raven 440. It did have a hydraulic pump. So what we did, we broke those same seeding rate zones out. And how did that, we correlated it back to his 2017 yield. And we variable rated this field, but it was with a manual rate. So I, used that grower's iPad. I used his Field Explorer app. I loaded his seeding rate map in the background. And as we were going throughout the field, the grower was actually able to, swap from rate 1 and rate 2. So don't feel limited if you don't have all the latest and greatest technology.
Just a common sense approach.
Right. We're just going to work with everything everything you've got to its fullest ability. So he used technology, but he had to work a little bit using
rate 1,
rate 1 and rate 2. And how I came up with my recommendations here is like we mentioned earlier, this grower went with a Y drop setup. We were going to band all his nitrogen with the Y drop. So I was like, well, if we're going to do a split application of nitrogen, if we're going to go with the Y drops, let's make these nitrogen recommendations at 0.8 pounds of nitrogen per bushel versus the grower's normal is right at 1. So it's saying, hey, you have this technology, you've made the investment on placing products better. Let's let these inputs, let's let you take advantage of these inputs as well. So broke these 4 zones out from his 2017 yield, and then what I did was, as the yield came through on those 2017 yield zones, I broke out the yield goals, obviously, and then tie that back to 0.8 pounds of nitrogen per bushel, and that's how I came up with my recommendations.
Environmentally friendly application as well.
Correct, yes. So as you can tell here, his pounds of actual rate, he had 168 was one rate, and then 200 pounds was the other rate for the two green zones. His 2018 corn yield result was 175, where he applied 168 pounds of N, and then how that correlated with his 18 corn yield was 220 and 239. I broke that out in cost of nitrogen per bushel as well. Ranged from 38 cents to 36 cents to 38 cents, 33 cents, and then the actual nitrogen efficiency in those 3 zones was 1 to 0.9 to 0.8, and then for our yield result, it ended up averaging out to 176 for the yellow zone, 220 for our light green zone, and 239 for our dark green zone.
I see that cost per bushel. It seems here that's really what we need to be focusing on. And managing into a profit.
Right. Yeah. And so when I meet with a lot of our growers, is we want to get everything seemed to be wrapped around the cost per acre, but it's like, hey, if we can reallocate your inputs, we can get your cost per bushel down. That should raise your farm averages up. How we ended up in this whole scenario was we applied an average rate of 186 units. Our 2018 corn yield result was 223 bushel. Our cost of nitrogen per bushel landed right at that 33 cents, and our actual nitrogen efficiency was right spot on where we wanted to be with 0.8. With the Y drops, where we got to that 0.8, we also recommended a MBPT stabilizer, had a high concentration of that to control volatility as well. At the end of the day, that was an average savings of $11 per acre with the increased nitrogen efficiency versus the grower traditional program.
Well, that sounds awesome.
So lastly, what I want to do is sit with the grower and say, hey, this is how we can scale this, or how we can manage this, and we can show you predictable results back to our, from the very start. This is very, this information is stuff that we can truth, and we can say, hey, we either paid for reallocating these inputs or we didn't. And this is a simple zone 4 through 1 or 1 through 4 of breaking those seeding rates out, and how that all tied back into, those 4 zones are really close to everything where we placed all our inputs. So with that broke that right out into yield. You saw that on the nitrogen map. Zone 4 broke it out to 239 bushel, where we put the majority of our inputs. Zone 3 was 220 bushel. Zone 2 was 179 bushel.
That sounds pretty good there, Dallas. It looks awesome.